Beecham and Eric Parris. We had a fifth member that could not be here. Sorry, Sabouh. We developed this game during Game Design 2 last semester. And the whole idea is that we picked a topic, a kind of game we wanted to design, and we pick our genre, designed our levels, then made our implementation. I'm going to go ahead and let Eric go ahead and start with his portion.
Do you want to say anything first?
Just that these guys did a good job. I'm looking forward to you guys all seeing it. Yeah.
What is Overkill? We're talking about what is Overkill, the game engine, our development process, and then show you guys the finished product, what it looked like after we went through everything. Well, your first question is probably, what is Overkill? It's actually the title of our video game that we created. It's an RPG or role-playing game. And in these kind of games, there's usually heavily emphasized story. There's usually character progression. And what that generally means is as you go through the game, your character is going to get stronger. You're going to do more damage, whatnot. There's usually some kind of combat with decisive battles against antagonists that you want to defeat. And there's usually large story quests with some side quests. And we aimed to create that kind of game, but due to time constraints, can only create the battle system. But I believe we did a fairly good job of it. And this is the game engine we use, Unity. And the thing about this engine is it's actually pretty good for game development, especially when you're making 3D games. And what it allowed us to do was not have to hard code everything from scratch, as we would have if we were to use some other language, if we had coded it in C++ or something like that. But because we used Unity, we were able to have things that were built inside of Unity that provided us with services that allowed our game to be made at a faster pace and far easier. But a majority of the game was still hard-coded, and we coded it using C#. Travis?
Okay. With our game, our whole idea was where do we start? And we decided that we wanted to have an idea of a turn-based fighting game. So we'll have an opponent, hits us, then it's our turn, just like chess. Then, so we decided we have to break ourselves up into teams. So what we did, we had AI, and we had movement and mechanics, and then myself, I was on level design, and we had Jonathan floating back and forth between, kind of helping out when we needed. And the whole idea is that our mechanics team and our AI, we started out with something super simple, like we have here with our technically these were our good guys, and over there you can see they're kind of dimmed out. Those were our bad guys. Later we skinned them with actual models to be our game. And I'll let you talk about
The next slide.
oh, next slide. Yes.
The progressives. See what we have.
So runway. There we go. Animations. What we did, we you can see we implemented a couple different models at a time, and our UI right there, it's pretty cool what we did. It's actually 2D items being projected from the back of the scene to hit the camera. That's what we did. So it's going to be scaled no matter what your UI is. And the whole idea of how we made these maps are that when you design, you have to think back at the beginning. You can't just jump in the pool and not swim. You have to think about what you're going to do and then do your implementation. We started out saying we wanted a medieval style game, medieval fantasy. Then we originally were going to have an overworld, kind of like Pokemon, You start out, you have a world you can run around in, and then you can go to a battle scene and fight your enemies. Due to our time constraint, we had to narrow down our scope a little bit, and this is actually where we start out with our battle scene. We had to hammer out the theme, and so we picked desert theme, forest theme, and the winter theme. We only showed the forest theme in this one. And basically what we did was we had to go in and draw our concept art and then build it in the game. Next slide. And here you can see it's a slight progression. Our UI is now, the buttons are now scaled down to fit this corner of the screen, no matter the resolution. We have now, instead of having two cylinders, we now have Zebulon. And then we also had our animated spider intro. All right.
And now we're going to show you the finished product before we get into the movement and whatnot.
So it's easier to understand what other Jonathan is talking about. There's sound.
Never signed all that.
Here it is. And here's our two characters. We have Zebulon and Darius. Okay. And then fire. And then I pick the target. And then shoot him. And if I pick him, Darius, fire. Look at me, blade rush, and pick. He makes a stabbing attack.
Now, if you notice, we have the hero's mana right here, and also this bar, which regenerates after they attack, and then your enemy's health and perspective mana. Top.
And now there's the troll attacking. Here comes the spider. And then I can also heal. And I can target which person I want to heal. And so I chose Zebulon and heal him. And then the mana began to regenerate after the timer regenerated and it took away some mana after I used his heal. Alright, now I'm going to have Jonathan explain the movement mechanics.
Yeah, just
There you go.
Okay, so my name is Jonathan, and I'm just going to talk a little bit about the math that went behind working with this game. Because, of course, one of the first challenges we have is how do we move these characters around in 3 dimensions. The first thing I want to talk about is the way we actually work with it, and it's very similar to what you would experience in like a linear algebra class or something. You have vectors, and vectors are your main go-to to be able to really regulate anything in terms of these 3 dimensions. As you can see, with Unity, there's a bit of a strange convention. Typically in math we have the vertical axis being the z-axis, whereas y is going to be going towards the right in this case. But actually Unity has x and z as the vertical, and in this case going out of the screen. But y in Unity is actually going vertically this time. Now, for every single object that you saw in the game, there is a location coordinate for it. And we are regularly interacting in the game to find these location coordinates and constructing vectors using these coordinates. And just to give a good idea of how we move from our beginning position to our goal, I have a very simplistic diagram here. So as you can see, we have the beginning of this vector is at the blue square. This is like I guess you can say it's like a bird's eye view of what we're doing. And this vector is just pointing from the blue square to the red square, and this is constructed by taking the red square's position coordinates and subtracting the blue square's position coordinates. This will give a movement vector that points in the exact direction we need, and then we can just change the length of that vector in order to simulate movement. Now, another thing you might have noticed is that whenever we're actually using models, they're no longer symmetric like we have with the cylinders. Now, these models are going to have to rotate towards a target in order to have realistic movement. This was accomplished with a bit of a more complicated algorithm, but it's not too difficult to explain. So if we go here, you see this green arrow is actually a stored vector in the game for every single object. It's called the forward vector. And literally, all we need to do is take the vector that is pointing towards our target and find the angle between forward and that other vector, and that will give us the angle of rotation that we need in order to simulate a realistic rotation. And this is the finished result, and as you saw in the game, that is how we got there. Now I'm going to have Eric talk a little bit about the AI and how we progressed with that.
Well, initially, the enemy AI would only attack the first character, one on the left, and continuously attack that character. That was the first step, and that was just to exemplify the fact that, yes, the enemies could move, yes, the enemies could do damage, etc. But we decided that doesn't make a good game experience. That's a bit too dumb of an AI. So we wanted to improve the AI. We made it so that the AI would choose to randomly attack a player and using an array of player characters. And after the character had taken damage, the enemies would mainly try to attack that character in an effort to finish them off, because it's easier to kill them than, fully kill the other guy. And then we decided that that was still a bit too dumb of an AI. What we wanted were enemies that, when they take damage, they could heal themselves and potentially make fights more strategic or difficult. So the enemies could choose to heal themselves when they're below 60% HP. They will heal themselves, or their ally, if their ally is the one needing health. That was something that was added eventually. Initially, they could only heal themselves. But an interesting thing about the AI that we programmed in was that the enemies, if an enemy was already healing for that set turn of the two enemies, the other enemy would choose to attack because the healing had already been covered and the health was already going to be restored, so they would go ahead and make an attack. In conclusion, we believe that video games are built upon a strong mathematical background and require lots of math in order to realize the game that you're trying to create. And we believe that it was a great exercise in teamwork between all of us, because different people bring different skill sets to groups when they join them. Some people are better programmers than others. Some people are better at visual design than others. Some people think of weird ways to solve challenging problems, stuff like that. Everyone has their own thing they bring to a team, and being able to utilize those resources properly was something that really helped us out in making this game. And we believe that behind every great game, there's a team with great technical, interpersonal, and creative skills.
Any questions?
Mm.